Circuit review. So looking at circuits, just a quick little review. When you're drawing a diagram, make sure you're looking at the negative side of the battery. Is that little teeny negative? Looks like a negative sign, and the positive sign is off on the left. And sometimes a bulb will look like this little weird bump, or you can look at as an X. Remember that a incandescent bulb that we were using is a resistor. And we have a switch right there. If the switch is closed, then we will get current. Positive direction. Looks like the positives are going to go this way. And so a circuit is similar to having like a water pump. So instead of having energy from a pump, the energy comes from the battery. And just like the water is already in the pipe, the electrons are already all in the wire. The electrons have a negative charge to them. There we go. But that seems kind of funny. Why do we look at the direction a positive charge goes? Because they didn't know what they were talking about when they originally saw it. So when you think of electric current or the electron flow, it's the direction a negative charge would go. So I'm going to close this little switch here. If I had a negative charge right here, it would want to go all the way around to the other side. So the electron flow is going to be going in the clockwise fashion, in my case. In conventional current, which is the one we use, so I'm going to circle it really big, the direction a positive charge would travel. So I put a positive charge and I look to see like charges repel, and so it's going to go around the other direction. Remember, that's just the only reason why we write it out. The direction a positive charge would go is because they didn't know what was moving when they first figured out about electricity. Resistance. Resistance is will determine the amount of current that will actually flow through the circuit. So remember, V equals IR. If you have a lot of resistance, having to go through all three of these, with the same battery, put the same voltage drop on each of these. I'll put even a little delta so we can see that's the increase in energy. Big, huge resistance, we're going to have a small current. And in this case, we have a small resistance, so we will have a larger current flow. This one's kind of average. So recap, voltage is the electric potential, the difference, difference in electric potential, measured with V, or volts. So if we have a battery, this is the negative side, that is the positive side. Positive side looks like a bump. I'm going to say the potential difference is 0 here. Or sorry, electric potential. Electric potential is 0 on the negative side. And on the positive side, the electric potential is 1.5 volts. So the difference between those is 1.5 minus 0 is 1.5 volts. So that's the voltage across the battery. It's the difference in the electric potential. So current is the flow of electrons. It's measured in amps. You usually put a big capital A. Resistance will slow the current flow down. It's measured in ohms. And remember, our relationship between voltage, current, and resistance is VIR. V equals IR. And we drew this out just to kind of for people to help do calculations last class. Thank you very much.